Hello guys, I hope you guys are doing well. The purpose of today's video is to present you with a demo of an ETL project utilizing Apache Airflow, Postgres, Power BI for advanced data processing. So here's the overview of the project. The purpose is analyzing internet log files for insightful data visualization. The goal is to implement an ETL pipeline using Apache Airflow, Postgres, and structure our data into some format. In our case, we will be using star schema, and at the end we will visualize it in Power BI. So these are the project requirements. We are given with internet log files. You can get the link to the log files in the description below. And tasks are to, as I have already mentioned, we have to visualize the data in Power BI or some other tool like that. Plus there are other requirements like we have to get stuff from IP addresses like geolocation, and there are requests from different web crawlers. We have to identify them as well. Tools we are going to use are Apache Airflow using Docker, Postgres SQL, and Power BI. ETL, in ETL, E stands for extract, T stands for transform, and L stands for loads. So for extraction, I have used Python to analyze the files, and then using Airflow to extract raw data. There were total 93 files. I will show you what those files look like in a moment. And there were arbitrary fields in those files. I have identified the number of different fields amount it had and added the hyphen in the cells of the table which have lesser fields. And then I have a staging area where I have stored information after extraction. After extraction, I have used Airflow to separate our data into different dimensions and factables. And then I have transformed the data, as I have mentioned before, looking at the requirement as well. So when I said dimensions, so this was the model that I was supposed to transform in a star schema, which is a physical version of this sun model. So in the middle we have my years and all the other things you see around it are the dimensions. So for geolocation management, I have extracted these fields: country code, country name, city, latitude, longitude, postcode, etc. And I have used IP info to extract those fields from IP addresses. And for the web crawler requests, there I have observed that there was robot.txt requested whenever there was a request from web crawlers. So I have looked for the request, having the request for robot.txt, and then I have saved those IPs so that I can use them later. There were some problems with data. As I have already mentioned, the fields in the files were not the same. Some files were the combination of multiple files. There were a lot of missing data, repeated IPs, and understanding or extracting data from those were quite complex. So when it comes to getting the IP information, as there are about 1.5 lakh records, it was quite time taking. It was taking about 45 to 60 minutes to get all the information or fetch all the information. So in order to make it fast, I have used multi-threading and memorization techniques for efficiency. And it was hard for me to get use of PostgreSQL in Python operators. So I have derived a way in which I have used Python operators to make the queries and Postgres to insert data in PostgreSQL. This is a basic flowchart diagram. So every component is connected to staging, and that's how they are communicating with each other. And then after transformation, data is being loaded in PostgreSQL, and then load it in Power BI for visualization. So in Airflow, we have DAGs, directed acyclic graphs. The one I have created in this project looks something like this. So as you can see, it's quite a structure. So it starts with looking for new log files in a folder named lobby, and then it will process the files which are not there in the table, make dimension, transform data, handle robo.txt in our case, which we want to detect if a request is from crawler or not, and then we create schemas and then make queries and then insert data and then load in Power BI. So this is the physical structure. Star schema I have mentioned before. So this structure is made after loading the files in Power BI. This structure ensures that you have successfully converted your Sun model in star schema. And then Power BI is used for visualization. Let me show you the files. So this is my VS Code. There were total 93 log files, and if I open one, you will see it looks something like this. This is what I meant with files are like combination of one or more. You see these headers, you will see these repeated headers multiple times in some files, and you can see that the information is like messy. There is no such thing as location and stuff like that. So this is my final report in Power BI looks like. So let me show you the tables. So you can see I have successfully extracted the information like city, continent name, country code, country name, etc. And I have seen the browser information from this field as well, user agent. This is the star schema that I have shown you before. And this is the report. You can see there are different slicers or button if you want to call them buttons. Sorry. So if you click on a quarter, it will show you the details of first quarter of the year. Similarly, 4th quarter of the year. For example, if I want to check which requests were made from which operating system, you can use it like, for example, if I click Linux, you will see the changes in the report. Same goes for continent. You can see that if I click Asia, everything from Europe is like gone now, and you are still in Asia. So, and this is the button for web crawler. If I remove this filter and this filter as well, so that we have like more data to check, and if I use all the information that was not from web crawler, I will just click false, and this here represents all the details are not from web crawler and from real users, and these are the details. Thank you very much. You can find the link to the code in the description below. Thank you for watching. See you again soon. Bye.